Okay, so I wanted to cover panels before the end of the course because we haven't really touched on this yet. Um, it comes in handy a lot in sort of financial or economic situations, but I could imagine more scientific settings where it would be useful also. So basically, if you can think of panels as sort of this third dimension of pandas. So if a series is a one-dimensional column or a row of data, and a data frame is a two-dimensional table which contains many series, then a panel is, or panels are, a set of data frames together. So it's one more level of dimensionality to your data structure. And this is actually the genesis of the pandas name, panel data, or pandas, is part of the name. So there are, just as we had indexes and columns in data frames, we have in panels, we have items, major axis, and minor axis. So items correspond to the data frames that are inside the panel. The major axis corresponds to the index of the data frames, and the minor axis corresponds to the columns of the data frames. So we're going to make sure we have pandas and NumPy activated, and then we're going to make a data frame that's a three-dimensional random number array. So this is a list of lists of lists, right? So it's a 2 by 5 by 4 array. And from that, we're going to generate a panel. So just like we have pd.series and pd.dataframe, we have pd.panel. So we're going to pass the data to that function. The items, or the names of those data frames, will be item 1 and 2. So that's that first dimension. We have 2 of those. The major axis will be the date range from February 25th, 1852, and then having the number of periods in that date range equivalent to the shape of this second index, or the second dimension, so that's going to be 5. And then the minor axis will be ABCD, which is 4. So just a way that we're entering the data here. And if we just look at that panel by itself, we'll see that it has dimensions 2 by 5 by 4. Those are items, major axis, and minor axis. The items index go from item 1 to item 2. The major axis goes from 225 to 229, and the minor axis goes from A to D. So it's smart enough to know that these are sequential, and or it may just actually just show us the first and the last. But anyway, it gives us some core information about the panel. So just as if we did data frame dot some string, that would be corresponding to the column names of a data frame. Doing panel dot some string is corresponding to the item names, or the underlying data frames. So panel 1 dot item 1 gives us this data frame, and item 2 gives us this data frame. So we have the major axis here are these dates, and the minor axis are these columns. We can also create a panel using a dictionary of data frame objects. This is again analogous to Pandas data frames, where you can have multiple series combined as the values of dictionary, and then the keys are the column names. Here we have the keys are the data frame names, and the data frames are the values, and then we're creating this panel. So we have panel dot item 1 and panel dot item 2. Same idea. With indexing, there's a few options, but it's basically analogous to what we've done with data frames. So just like with data frames, instead of doing a dot notation, we can specify the name of that data frame in brackets and then in quotes. So this gives us item 1. And then we can look at the axis labels just to check what they are. So panel 1 has these major axis labels. If we want to get all of the data in this panel corresponding to this major axis label February 25th, we can use the major axis, major XS slicing function. And so what this is doing is creating a new data frame that has the column names correspond to the original data frame names, and the row names correspond now to the original column names because the original row names were this date. So it's just sort of re-slicing this panel in a different way to condense it down to a two-dimensional data frame. So this gives us the same thing here, except for now we're using the axis label using a numerical index instead of a string. Same thing with minor axis, so we can view the minor axis and then we can use minor underscore XS with the name of one of those labels, with the name of one of those index values, and it'll slice the data frame that way. So now we don't have A, B, C, D in our data frame. We just have the dates and the data frame labels. Finally, we can also do operations. So let's say you have two data frames that have identical values, or not identical values, but corresponding values. Like let's say you had precipitation data for every day of the year for 2017 and every day of the year for 2018, and you wanted to look at the difference in precipitation on a daily basis between those 2 years. You could subtract one data frame from the other using the panel construct. So in this case, we're taking item 1 divided by item 2, and since they have the same dimensions and everything is analogous, we can create a new panel that's item 3 that then has these values here. So it has the same row labels and same column labels as those two original items. There's a lot more information about panels at this link here. If it's something that looks useful to you, like you're dealing with data over multiple years, that's the same. You might find this as a good way to store your data. Any questions on panels?